So I'm selecting plot 1, but it is off. So let me turn plot 1 on by hitting enter. So we know how to do this, and it's in there are videos in the book, by the way, so the ebook. Okay, so now I turn plot 1 on. I want to tell my calculator that I'm doing scatter plot, a statistical plot called the scatter plot. That's what I just told my calculator, but I haven't said that until I hit enter. So I told my calculator that I'm doing a scatter plot. And now my calculator is asking me, do you have the X list? Where is it? Notice that my X list is in L1, so it's correct. My Y list is in L2, that's correct. My input and output are in L1 and L2. Any questions so far? Remember, this is in Blackboard. These are where the videos are. So you can go there and watch this video, the videos. And I'm recording this right now, which means you can watch this one. Okay. And then the next thing is, sometimes you want to check your y equals and see if there is any equation there. If there's any equation there, you clear that. Otherwise, it's going to screw you up. So there is no equation in my y function. I can now zoom 9. If I zoom 9, I'm telling my calculators to graph a statistical plot called scatter plot. So I hit that, and it says quit. So let me go and see what it's telling me. Oh, see, there is a function in my y1 or y, so I'll clear that. I'm going to clear that because let me see if there's any other function. There's another function right here. If I don't clear them, then it will not let me. So I'm going to go back, second quit, and zoom 9. Okay, right now it drew a scatter plot for me. Is that the kind of thing you have? And the question, is that the kind of plot you have? Okay, so we have drawn a scatter plot. Suppose it is linear. We are supposed to, I'm told to draw linear, but in unit 2, we might be told to draw quadratic function, a quadratic model. So let me try and fit linear there. But when I eyeball my scatter plot, it doesn't actually show me that it's linear. It's kind of exponential. Did you see my scatter plot? It looks exponential, right? So, but in unit 1, we are doing linear. That's why we are doing slope, equation of a line, and we are going to also see simultaneous equation by substitution, by elimination method. All right. And so I'm going to try to model a linear equation there. But guess what? It doesn't actually look linear. In unit 3, we start doing exponential. And so we shall try exponential. We shall actually try quadratic. We shall try logarithmic. Logarithm. So in unit 3, we start talking about logarithmic equation. And so we try logarithmic. We try, there are so many other ones we shall try. Okay, quartic equation, cubic equation, polynomials. Okay, so let me try and put linear function there. But so how do I put linear function? I'll go to start, STAT, and I will go to calc, and I want to select linear function. You see that number 4 is linear, right? You see number 4 is linear? And also, you notice that number 4 is linear, and number 8 is linear too. In number 8, the slope is B. In number 4, the slope is A. I like to choose number 4 because it looks like slope intercept form. So I'm going to select number 4. And I don't have to tell my calculator that input is in L1 and output is in L2. Because if I don't, it's going to actually assume that my input and output are L1 and L2. But if my input is in L3, L4, I must tell my calculator. So I'm going to actually hit enter here. And it gives me that the equation, let me write that equation according to what I have here. So I'm going to write the equation. I don't know if red or is this focused? Is it focused? I think it is. So let me write the equation. So the equation of this line, according to my linear function, says that, all right, says that y or f of x is equal to the slope is 28 point. I'm going to leave my answer to 3 decimal places. It's 28.1398, which is the same as 140. 28.140x. So that's the slope. The y-intercept, according to my linear equation, is negative 33.10103. So I'm going to put negative here because 33.105. 103. Okay. When we get to Math 120, which is statistics, then we start talking about R squared. The R squared tells us that the kind of relationship between X and Y is a high positive, 84%. Okay, so we shall explain that when we get to 120. But for now, we know that the coefficient of correlation is 91.812. And that shows that there's a high positive linear relationship between X and Y. High positive, not negative. Okay, but the important thing now is just the equation in this class. Just the equation, that's it. When we go further, we shall be interpreting R squared and R. So we know how to do the scatter plot, and we know how to find the equation, right? It's in the test next week. So you really want to go back and go back to the ebook and watch the videos, try to do it with your calculator. Is that clear? All right, the next thing we want to do now is solve a system of equation in 2 variables for now. I know you did it in Math 101, maybe. If not, we shall do it by substitution and by elimination method. We shall also do it by graphical method. But before we start, we can just say systems of equations. Systems of equations. Suppose I have line 1 and line 2. Let's just make a definition. If line 1 crosses line 2, line 2 at the point A, B, where A is the X variable and what B is Y variable, we say that there is one solution. So one solution, please look at the PowerPoint. One solution, that means that these 2 graphs are consistent. So whenever you are told to check and see if they are consistent, it means, do they have one solution? Number 2, if L1 and L2 are parallel, L1 and L2 are parallel, which means slope of line 1 is equal to, which means that slope of line 1 is equal to slope of line 2. Then we say, yes, can you see?
What does that say at the top? System of what?
Consistent.
No, above it.
Above it, one solution. One solution means there's only one point. They have only one point of intersection. They have only one point of intersection. So the solution is A, B. We're going to see one now. One point of intersection. So they are consistent. If the 2 lines are parallel, which means they have equal slopes, we say that the lines are inconsistent. Inconsistent. And so we will say, is there any solution? In other words, is there any point of intersection? Any questions? When lines are inconsistent, they are parallel. And so we say no solution. We say no solution. All right. There's another case. Case 3. If the two lines L1 and L2 are the same line such that they overlap, we say many solutions or infinitely many solutions. Many solutions. So the lines are the same, L1 and L2. They overlap. Every point in L1 is in L2. You say infinitely many solutions. It has many solutions, infinite. In other words, the slope of the first one is equal to slope of the second one, the x. Y-intercept of the first one is equal to y-intercept of the second one. Now, step number 4. So we have talked about one solution when they intersect, no solution when they are parallel, and many solutions. Okay. Okay, let's stop at this 3 and let's get to the function. Let's go to, and I want you to know that this is section 1.3, and this is your homework. I am just going to, let's get some questions here. If I don't see a question, I'll go to, I'm going to go to practice test because we need to be, okay, I don't see what I need here. So let me go to the practice test, which I sent to you. I sent you a practice test, so let's go there. Go there. And then I picking this practice test. Picking this practice test. And so this is unit 1 practice test. And if I were you, I'll be working problems from here. Remember, we talked about the difference quotient is in the test. Solving a system of solving an equation, it's in the test. Okay, solve a system. Do you see solve the system of equation by substitution method? So this is what I'm talking about. You'll be doing the homework, but if I were you, after doing the homework, for some time, I'll go and look at the practice test. It's good to look at the practice test. That's why I gave it to you. Suppose I just pick that practice test the way it is and give you as a test. I can do that. And remember that it's not going to be the same numbers. Numbers will change. Okay. So you can see the practice that I'm going to do number 22. So let's copy that question and do it. Number 22 of the practice test. And I have x equal to 3y plus 10. And I have 4x plus 5y equal to 6. Okay. I want you to attempt this because I know there are 3 ways quickly you can solve a system. You can solve it by elimination method, you remember, or substitution method from your previous class, or by graphing. So try the easiest one to you, and then I'll come back in 2 minutes. Use either elimination or substitution or graphical method. And then I come back, we're going to do it together. Okay? Bye. Okay, so I know you're trying the method you like. So the first method I want to do first for you, if it's a test, the method I want to do first is substitution method. So substitution method. I know the substitution method is going to be easier for me because one variable is already isolated. That's why I think it's going to be the easiest method. So let me substitute equation 1 in equation 2. Substitute x in equation 2. Substitute x in equation 2. So the value of x is this. Whenever I see x in equation 2, I will put in 3y plus 10. So right here, I have 4x, 4. Instead of writing x here, I will write 3y plus 10. And then that equation contains 3y plus 10 plus 5y equal to 6. So the essence of substitution is to convert the equation to one variable. So now this is an equation in one variable. I can now distribute 4 into that equation. Are you following? Is it clear? Is that clear?
Mm-hmm.
All right, so distribute. The person online, can you see? Are you following? Jemiah?
Yes.
Jemiah, okay, can you follow? Are you following?
Yes.
Okay. And then when I distribute 4 times 3 is 12y. 4 times 10 is 40 plus 5y is equal to 6. Collect like terms together, and 40 and 6. So I have 12 plus 5 is 17y on the left-hand side, and I subtract 40 on both sides. So I have 6 minus, very good. 6 minus 40 is negative 34. Do you agree? 17y is equal to negative 34. 17, divide both sides because I want to find the value of y with the coefficient of 1. 17 going to 34, negative 2. So y is equal to negative 2. Do you agree? All right, now that we have found the value of y, we can back substitute right here, and find the value of x. So x is, y is negative 2. Then I can find the value of x here. So go ahead, I will say x is equal to 3, substitute what the value of y plus 10 Is that clear? And then 3 times negative 2 is negative 6 plus 10 is equal to 4. Therefore, the two equations intersect each other at the point x, y. Notice that the first coordinate is x. So I have 4, comma, negative 2 at the point 4, comma, negative 2. So we solve the equation by substitution method. Let's quickly solve the equation by graphical method. Let's solve the same equation by graphical method. Anytime we are solving by graphical method, we have to isolate y on both sides. So let me write the equation 1 again. Graphical method. Graphical method. So I'm writing the equation again. X plus 3, x is equal to 3y plus 10. And I want to, let me rewrite equation 1. So minus 10 on both sides. X minus 10 is equal to 3y. Divide both sides by 3. I have y, now I have x minus 10 over 3 is equal to y. So I have isolated y. Is that okay this way? Y can be any side. It can be at the right-hand side or left-hand side. Are we together? Hello, are we together? Now I want to isolate y in equation 2. So I'm going to bring down equation 2. And that is 4x plus 5y is equal to 6. I want to isolate y in equation 2. So I can let y be on the left-hand side. So if I do that, I have minus 4x on both sides. And divide, I have 5y is equal to 6 minus 4x. Then I divide both sides by 5 because y has got to be alone on divide by 5. All right, so now I have y is equal to 6 over 5 minus 4x over 5. Now, let me rewrite this equation in standard form, slope-intercept form. Okay, so the equation 1 is going to be y equal to x over 3 minus 10 over 3. I just rewrote it. And then this is already in y equal to, this is already in standard form. So I'm going to rewrite it here, 4x over 5 plus 6 over 5. Okay, now I put them in, since now I have isolated y, I can put them in y1 and y2. So turn your calculator on, go to y equals. Before you start, everybody, remember that you cannot, it will not let you graph any function if a plot is on. Do you agree? So de-highlight the plot that's on. So now I'm going to y1 and I'm going to substitute the equation 1 in y1. Okay, so I have x divided by 3 minus 10 divided by 3. So x, I can use parentheses if possible. If you have any problem, you can use parentheses. X divided by 3, close parentheses. And then you go to minus. You can use parentheses again. That way you don't have any problem. So I'm going to write 10 divided by 3. 10 divided by 3, close parentheses. So that is my equation 1. I'm going to go to equation 2. So my equation 2 is negative 4x over 5. So I'm going to put negative there. Then I'll use parentheses because it's a fraction. So I'm going to put 4x divided by 5. You can use decimals also. And then plus 6 over 5. Plus 6 divided by 5. So this is what I have. And when I go to my windows, let me check my windows. I don't like my windows. I want to change my windows to maybe negative 20 to 20. And then I can change it later. So negative 20 to 20. And then I want to see if I can have a complete graph. If I have a complete graph, I will have the point of intersection. So minus negative 20 minus 20 to 20. And then later on, I can use negative 10 to 10. Let me see if I can get a complete graph. The complete graph must have the point of intersection. So I have a complete graph. Now let me change that window again to negative 10 to 10. Let me change it to standard windows. Go back to Windows, and I'm changing to standard windows, negative 10 to 10, and I'll arrow down to negative 10 to 10. And then let me graph again. I want to see a complete graph. Yes, I did. Is that clear? So you haven't answered the question though. The question is, what is the point of intersection? We already know the answer. We know the answer from substitution method. So it doesn't matter any method I use. If I use substitution method, I get the same answer. If I use the elimination method, I get the same answer. If I use graphical method, I get the same answer. If the answers are different, then somebody screwed up. So when you're given the question to solve it by, if you're told to show work using substitution method, go ahead. You are told to show work, but if you're not told to show all work, if the question just says solve, then go ahead and solve the method you know, okay? So by graphical method, I want to find the point of intersection of these two graphs. So let me use I didn't know what it is from my answer here. I know it should be 4, negative 2, but let me see if my graphical method is the same also. So I'll go to intersection. I'll go to second calc, and I'll ask my calculator to give me intersection. Number 5, and it's asking me, is that the first curve? I would say yes. And it's asking me, is that the second curve? I'll say yes, because it is. It's asking me, do I guess the point of intersection? Sure, guess. And my calculator guessed it right for negative 2. Do you see what I'm saying? So it doesn't really matter which method you use. If you know what you're doing, your answer will be the same. Is that clear? Let's do the same question by elimination method. The reason why I'm doing all this is, if you forgot it, please go ahead and review and know. Let me see if do we have time? Yes, we do have time. So let's do the same question with the elimination method. We solve one problem with graphical method, substitution method, then the next one is elimination method. We will have time. I will show you how to use calculator to solve a system of equation by reduced row echelon form. Okay, so we can use matrices to solve it also. We can use matrices. All right, so we solve by 2 methods here. We're going to elimination method. So the same question, another method. Is it going to be the same answer? It better be. If it's not the same answer, then somebody screwed up. All right, so this same question, number 22, in the practice test, I want to solve it by elimination method. So I'm going to copy the question down. X is equal to 3y plus 10. 4x plus 5y is equal to 6. But the question says solve by elimination method. All right? So we do that. But before I solve by elimination method, the question has to be in a standard form. And it's not. Y1 is not. Equation 1 is not yet. So I'm going to rewrite. So I'll rewrite equation 1. I'm going to bring y to the left-hand side. So x minus 3y is equal to 10. Now it is in standard form. Now equation 2 is in standard form, so I just have to copy it down. Plus 5y is equal to 6. So equation 1, equation 2, because I'm solving by elimination method. And then I'm going to ask myself, which one is easier to eliminate? It doesn't matter to me. I can just multiply equation 1 by negative 4. Do you agree? Multiply equation 1 by negative 4. So equation 1 multiplied by -4, this one right here. So -4 multiply equation 1 and bring down equation 2. And when I do that, I have -4x plus 12y is equal to -40. Do you agree? Hello, everybody. Trying to solve by elimination method. Bring this down, bring equation 2 down. 4x plus 5y is equal to 6. Add equations 1 and 2. The essence of multiplying by the negative coefficient of x is so that x can cancel. That's why. Now we collect y, and that is 17y is equal to -34. And divide both sides by 17y, we have y is equal to -2. We are solving a system in 2 variables. We only have one answer. Are we done? No. We need to find the value of the other variable. So we do that in equation 1, original equation 1. Wherever I see y, I put -2. That is x equal to 3 into -2 plus 10. And so x equal to 4. Now I can write the solution in parentheses. You have to write the solution in point form. So 4 -2. Therefore, the solution of the equation by elimination method is 4 -2. The solution of the system by substitution method is 4 -2. The solution of the system by graphical method is 4 -2. Is that clear? It must be the same answer. It doesn't matter the method you use. I'm going to show you how to do it by matrices. It's not, this one is not in your syllabus. But guess what? You need to know this. You need to know how to do it by matrices. No learning is a waste. I will show you that later on because it's not actually in but if you know it, it's not a waste of time. Any questions? That's a whole lot to review. That's a whole lot. Do you know that? Yes, sir. Me too. I lost it too. Me too. Okay. I'm going to look for it. 2 point. That's a good question. So I'm going to look for 2.2. I will put it there. Thank you. Section. Yeah, they are going to be all the. Yes, chapters 1 and 2. Chapter 1, section 1 to 1.1 to 1.4. Chapter 2, 1.1 to 1. Okay, 2.1 to 2.4. They're all going to be in the test. Okay. Good question. Any other question? Any other question? That's a lot to review, okay? So, you just push yourself. Make an A. Make an A in this first test, okay? All right, see you Friday. Any question, Janaya? Any question?